In this lesson, we'll talk about graphs of equations.
The graph of an equation, we just want to find some points that solve the equation. One way to do this, and to actually get a graph of all the solutions, is to plot a bunch of points and get a feel for which graph seems to fit the points that we've plotted already. So with 2x minus 3y equals 6, what I would do, just to make this a little bit easier, is go ahead and solve for y first. Now you can plug in points and go from there immediately, but I think it's easier to solve for y, so you can plug in an x and get a corresponding y. It goes pretty quick. So if I solve for x, I'll subtract 2x from both sides first, and I get 6 minus 2x, and then I'll divide by negative 3, and splitting that up I get y equals 6 divided by negative 3 is negative 2. Negative 2 divided by negative 3 just gives me a positive 2/3. Alright, so let's pick some points. Let's do negative 2, negative 1, 0, 1, and 2. So I'm picking the x-coordinates, and this equation will give me the y-coordinates. So if I plug in negative 2 for x, I get negative 2 minus 4/3, which is negative 10/3. So negative 10/3. When I plug in negative 1, I get negative 2 minus 2/3, so that's negative 8/3. Alright, so negative 8/3. When I plug in 0, I'm going to get negative 2. And just to follow this, it looks like I'll get negative 4/3. And also at 2, I get negative 2/3. And so let's plot all these and get a feel for what this graph looks like. So negative 2, negative 10/3 is 3 1/3. So somewhere right around here. Negative 1 and negative 8/3 is 2 2/3. We've got 0, negative 2. And then 1, negative 4/3 is 1 1/3. Then positive 2 is negative 2/3. And if you were to keep going, you'd see this path that appears to be a straight line. Let's draw the line through these points, and that's what we're going to guess is the graph of this equation. Next two examples. So x squared plus y squared minus 4x equals 0. So it looks like if we plot some x values, we'll get some y values. So let me solve for y. So I'm going to get y squared by itself first. So if I do that, I'm going to subtract x squared from both sides and add 4x to both sides. Y would be plus or minus. Remember, that's important every time you take a square root. Negative x squared plus 4x. We need to put some values in here. Now some of these might not even work. We got to think about this is a square root, and I see 0 works. If you plug in 0, you certainly get a quick, easy answer. Let's just try negative 1. So if I do negative 1 plus or minus the square root of negative 1 squared plus 4 times negative 1, that's plus or minus the square root of negative 5. Now we can write that with an I, but i's don't get graphed. I's are imaginary numbers, they're not real numbers, and the plane is made up of real ordered pairs. So there's nothing here. Alright, let's try 0. At 0, I get y equals plus or minus the square root of 0 plus 0, so that's 0. At 1, I get plus or minus square root of negative 1 squared plus 4 times 1. And that comes out to be 4, and negative 1 is 3, so plus or minus the square root of 3. So we get two different values here. At 2, plus or minus square root of negative 2 squared plus 4 times 2. That's plus or minus, that's negative 4 plus 8 is positive 4, so plus or minus 2. I'm going to do 3 and 4. At 3, I'm going to get plus or minus square root of 3. And then at 4, 0. And so let's plot these points. A little bit strange, but let's see what we got. 0, 0 is a point. 1, and then square root of 3 is about 1.7. So I need to do positive and negative square root of 3. Alright, at 2 I need to do plus or minus 2. At 3 it's again the plus or minus square root of 3, and at 4 I get back to 0. And if you try plugging in 5, you'd get negative 25 plus 20, so again it's no good. It turns out that the points that satisfy it are all in this range from 0 to 4, and this looks a lot like a circle. So I'm going to assume that this is a circle here. Y equals x squared plus 2x. Let's do the same thing I did in the first example. It's already solved for y, so I don't have to do as much work. Let's just do negative 2, negative 1, 0, 1, and 2. So at negative 2, I get negative 2 squared plus 2 times negative 2. So that's positive 4 plus negative 4, which is just 0. So at negative 2, I get 0. At negative 1, negative 1 squared plus 2 times negative 1. 1 plus negative 2 is negative 1. Next one, I think you can see the 0, but I'll write it down. Plug in 0, you get 0 again. At 1, 1 plus 2 is 3. At 2, I get 4 plus 4, which is 8. That's a little big. I get negative 2, 0. Negative 1, negative 1. 0, 0, 1, 3. And I can't really plot 2 8s, so I'm not going to. It might benefit me to see a value for negative 3, though. Just kind of figuring out what's going on here. So let's do negative 3 is what I want. Negative 3 squared plus 2 times negative 3. That's 9 minus 6 is 3. So negative 3, 3 is on the graph. And now this, if I was to make this shape, this is actually what we call a parabola. And it looks something like this little U shape. And so there's the equation. Somewhere up here I'd get that other point 2, 8. It'd be up here somewhere is where it would reach. And I'd probably run into something like that at negative 4 up here somewhere also. So if you have a linear equation in two variables, we can write it in the form ax plus by equals c. We often call this the standard form of the equation. And so x and y are our variables, and a, b, and c are numbers that for a and b are coefficients, and for c is some constant term in the problem. The idea is that if we can write an equation in this form, then it is a linear equation. So in order to find the x-intercepts and the y-intercepts, we let the other variable be 0.
Now we can talk about other forms of linear equations as well, but we really don't need to do that right now. We can just write any of these in standard form as desired. So one of the things we want to talk about with these linear equations is the intercepts of the linear equation. So in particular, an x-intercept is a point in which the graph intersects the x-axis. And so what this is going to look like is you're going to see a point where you've got some value c and then y equals 0. And that means we are definitely on the x-axis. Similarly, a y-intercept is where the graph intersects the y-axis, and so you've got some number with an x-coordinate of 0. And that's how we know that it's on the y-axis.
For this example, what I'm going to do is look for the x-intercept, and that means let y equal 0. I get 2x minus 3 times 0 equals 6. So 2x equals 6, meaning x equals 3. Alright, so 3 is not the answer though. 3, 0 is the x-intercept. The y-intercept will let x equal 0. We get 2 times 0 minus 3y equals 6. So negative 3y equals 6, and consequently y equals negative 2. Again, that's not the answer. We let x be 0, so it's 0, negative 2. So these are our two intercepts. Now if we want to draw the graph, all we have to do is plot these. 3, 0, 0, negative 2, and draw the line between them. We plotted this one in the previous lesson, but now we got it a whole lot faster. Next example. First one here, we're going to have to get it in standard form. So let's distribute the negative sign. Minus 4 minus 2x plus 5y equals 6. So we get 2x plus 5y, and I'm going to add the 4 to both sides, equals 10. So I combined the 4x and the negative 2x to get a positive 2x. The 5y remained, and I added 4 to both sides. So here's the equation in standard form. Now let me show you a trick. This is called the cover-up method. So if I want to know the x-intercept, I would let y equal 0. So what you can do is you can use your hand and cover the y term, and that will give you a new equation. So what you would see is just 2x equals 10. So here you go. That means x equals 5, so 5, 0 is one of the points. Now let's cover up the other one. If I want to know the y-intercept, I'll cover up the x part. So just put your hand over the 2x. Notice you now have 5y equals 10. That means y equals 2. So 0, 2. It's a very fast, easy way to find these intercepts. We just use the cover-up method. So we get 5, 0 as one of my x-coordinates, and 0, 2 as my y-intercept. If I draw these things, I get something like this. So there's the equation of that line. Alright, next one, you see it has a star on it, so feel free to pause this video and give it a try real quick, and then we'll do it together. So let's use the cover-up method that I mentioned. To find the x-intercept, what I need to do is cover up the negative 3y term. Just cover it up. Well, we see 4x equals 12, so clearly x equals 3. That's the point 3, 0. Pretty quick, isn't this cover-up method? Next, we want to find the y-intercept, so let's cover up the x term. Just put your hand over it. You see negative 3y is equal to 12, so y is equal to negative 4. So there's 0, negative 4. And that's all we have to do for these. So now we can plot our points. 3, 0, and 0, negative 4, and draw the line.